Hi guys, welcome back. I just want to do a quick video on this silicon heater that I've purchased. It's only just arrived, so I haven't installed it yet, but it's a 300 by 300 mil square silicon heater by Kinovo. They're a very well known heater manufacturer. I believe it's a legitimate Kinovo made one and not just a copy, but yeah, so it's arrived, it's here. It's 750 watts at 220 volts, which I know is not UK voltage. We're 230 nominal, and I've been online and checked the manufacturer's data sheet, and these are rated for up to actually 300 to 400 volts. So this is actually the wattage output that it gives at 220 at 50 hertz. So that's the nominal wattage of this. It will withstand 230 volts, 240 volts, not a problem. So for anyone who's wondered, oh, it's only 220, no, it's not a problem in the UK. That's fine. In some areas of the country you'll find that's all you're getting anyway. So yeah, sometimes some places are a little bit more, depends where you are in the country. But anyway, so this is my new heater, 750 watts, which is a little over 5.3 watts per square inch. So this shouldn't have any problem getting up to temperature. I was previously using this, which is it Mark? Not sure. Is it Mark III? Someone may be able to tell me. But anyway, it was wired for 24 volts, and I could get this up to just over 100, but it would take quite a while to get there, and to hold the 100 it would always be pulsing on. I had nothing more on this than a 2mm thick piece of glass, so I had no insulation on the bottom, so that didn't help. But yeah, it served the purpose. I may have to reuse this for a minute. This was the one that got damaged when I had my little accident. This got crushed and pressed down and smashed the glass, and I've taken it off in hope that I'll fit this one, but I don't have a piece of glass for this yet. Yeah, I may just purchase one online. I've contacted a glass supplier and had a quote for some 4mm toughened glass, which was a bit more than I thought, but it will come with polished edges, all smoothed, and maybe even some magnets recessed in it yet, I don't know. So for a minute I shall just get this mounted, but the same again, I'm not sure if I'm going to mount this on aluminium or whether to put this on a decent piece of copper. At the end of the day, this was quite an expensive heater. I hope it will last. I presume it's going to last. It's going to go in here somewhere like this. It's a little bit bigger than my build area. My build area is actually 290 by 290, and this is 300 mil square, so it's a little bit bigger than what I can print, but I'm glad of that, because it means my heating area will overlap where my print starts, so that should help if anything. So yeah, it's going to go somewhere there, but I need to get a base plate for it to go on, and yeah, obviously some leveling springs and some glass cut for it. So I'll let you know how that goes. It shouldn't take me too long to get that sorted, but I'm looking forward to trying it. It comes with 3M sticky backed lining, which I presume is a heat resistant adhesive. I suppose it's got to be. These things do seem to be rated quite well, and it appears to be built quite well. It's only one way to try it, and that's physically use it. So we shall see what happens. If anyone's had any bad experience with these, then please let me know. My only concern is, obviously that's mains voltage, and obviously the cables are going to be mains. Yeah, my only concern with using mains is quite simply, I've had the problem with this. I've got a heater down here. Now, this is just a heat sink that I've reused, and on the bottom there's nothing more than the base of an old iron. Now that's 2000 watts. I've cut the Bakelite lid down so that it's got some insulation on it. You can't touch anything electrical. It's got 2 thermocouples on it. There's one thermocouple there, which is actually on the element. That aluminium goes straight into the element where the element is clamped underneath of this plate. And I've got another thermocouple just clamped onto the heatsink itself. And yeah, I was just testing it really. I was trying a couple of heat sources, and it was being thrown out, so I thought I'd use it, and it works very well. Obviously, it's a heating element, so gets this very hot very quickly. But I'll explain my concern with the mains with these, and with anything mains in a printer. I mean, that's why most manufacturers and everyone's tried to stick to 12 and 24 volt. Is you can't really kill yourself with it. With mains, not only can you kill yourself, but you can burn your house down and kill everybody in the house with you. And I know people leave these things running overnight, so I'm going to add some element of safety to this so that it can't burn my shed down at the moment, but this one day will go into the house, and I'll make sure that it can't burn the house down. But anyway, back to this problem. I fitted a heater to this, so very simple, yeah. Just a heat source. Just at the moment, just simply chock blocked. It's all crimped, and it's earthed. The chassis is earthed. Everything is earthed very well, so not a problem there. It's fused correctly, but what is actually calling this to switch on is one of these solid state relays in the back. So in the back there is a solid state relay, and there we go. So there's 1, 2, there's another one in the back somewhere. There's 3, 1, 2, 3. Anyway, so one of those switches this on, and it's controlled with a Mega, nothing more than an Arduino Mega. So AT Mega is just a copy of Arduino. It's not an original Arduino. It's a Chinese copy. But anyway, so it's just a Mega controlling this. And it's just got an OLED on it at the moment. I just threw this together just to try and test it. It isn't what it's going to be finished. I just wanted to, yeah, just try it really. So what I've got, I can't get very close with this camera. So it's reading the ambient temperature. The set temperature for the chamber was 50 degrees. The set temperature for the heater heatsink was 150, and it's actually reading currently 0.722, which I know is wrong, but what it is, I'll explain one thing at a time. So anyway, this heater is controlled by an Arduino. This Arduino has got a thermocouple board. That's a Max thermocouple board in there. And at the moment, this is part of the problem why the thermocouple doesn't read correctly. A lot of people just plug these thermocouple boards directly onto... I really do apologise. You can just plug the thermocouple board directly into the Arduino and not connect the 5 volt and the... Come on, camera. Oh, I'm so sorry. Yeah, see there, that's just plugged directly into the header on the on the Mega. Now what it is you basically pull one pin up and one pin down, and you provide the 0 volts and the 5 volts. Unfortunately, it doesn't couple the power supply very well on these chips, and it creates an offset in the temperature reading. And here's the offset. You can see that's not reading properly. That's reading 0.722. Now what happens is, if I actually switch the heater on and heat, you'll see the temperature jump up extremely quickly. But anyway, it's not, that temperature is probably about 15 degrees out, and it's to do with ground looping, and most of that is, like I say, because that board is not plugged into the, it's drawing the power from input pins, not from a clean power source. But I'll sort that later. But anyway, so this heater is controlled via this Arduino, and as you can see now, it's waiting. It's not heating, it's waiting. So it's got up to temperature. Well, it's gone past temperature because it's overshot. Oh, this camera is flipping absolutely useless. Right. So it's waiting, it's not heating. I've actually got just a neon there just to see when it is coming on or not, just so I know it is on or not. And that's directly to the mains of the heater. So if the heater's got power on it, that neon has got power on it. There we go. And obviously it's heating. Nope, now it's waiting, heating, waiting. And it will try and maintain that 150. It's not a very good PNID loop in there. It's just a quick sample actually, and a timed thing, so it's not accurate. It's not really meant to be accurate. But what can happen is, these Megas, using external sensors, especially if you're using like a Ramps board or a Rambo board, or boards that plug in, daughter boards, you can create noise through a lot of all this wiring. Now I've screened my cables, I've shielded my cables, and I've grounded all my cables out to try and keep noise down. But this Mega, because this is wired the way it is, and because it can pick up noise anywhere in here, this has locked up, and the Mega locks up, and it locked up with this switched on, and this heater got up to about 540 degrees, and it done that whilst I was sat here basically doing other things but watching it. So I saw what happened, and the Mega locked up, the program completely froze, and it was through noise of switching these relays, and the noise fed back through and locked this up, and locked it up whilst it was in the heating cycle, and held that on, and that heater stayed on, and so did obviously the solid state relay. So that just held that on and on and on, and must have held it on for you know, good 10-15 minutes, and that 2000 watts heated that up fairly quickly, to the point yeah, you couldn't get near it. Obviously I come over and switched it off and no harm done, but had that been left, yeah, that could have been a mess. And obviously, was that in your house? Yeah, very dangerous. So if you are wiring mains and you're wiring heaters, then just be careful. And if you are wiring or adding to, you know, using Megas or Arduinos for switching power or switching anything that gets hot, just bear in mind these things can lock up. Now obviously I've sorted the electrical issue that caused the noise, and I've also put a watchdog on this Mega, so if it does lock up, it resets and it switches all the outputs off. So that in theory cannot happen again. That's not a guarantee, but in theory, by reducing the electrical noise and by applying a watchdog in the software, that shouldn't happen again. However, that's not really what that doesn't make me want to have total confidence in that, because I know that you know, it's not a real safe system. I deal with safe systems at work, and that would not be classed as a safe system. So what you can do, and what I probably will do, is add a temperature switch. Now this is a Clixon. This isn't the one I'll be using. I have got ones that are at the right temperature somewhere. You can get these various different temperatures. I'll just put the camera there for a minute and I shall open this up. So what I would advise anyone to do, if they're using a Mega or they're switching mains and they're relying on a Mega or your ramps or whatever, fit something like this. It's a temperature switch. This one is 100 degrees C, and it's normally closed. It's a normally closed switch. Come on. And at 100 degrees C it will open, and so if you put whatever across there, it will open circuit and switch off your heater. So these could be a lifesaver. They're fitted in all mains domestic equipment in your house, in your cooker, in your heater, in a lot of electrical appliances these are installed. Sometimes there's even two installed. Photocopiers and laser printers, that they have loads of these things in them just to regulate temperature. But so yeah, if you're gonna put a heater in your printer and you're gonna switch it with a Mega or with an Arduino, doesn't matter what it is, a Mega, a 328 Uno, a Duo, or whatever you're going to switch, you know, put some protection in there, especially if this thing's in your house and that's heat. And I probably would say the same for that. I'm going to try and find a way of putting some protection on that. That's probably not going to apply itself very well to the application, so I'm going to have to do something different. But yeah, just be cautious, obviously, using mains and using this much power in a printer. Now obviously mine's majority made of aluminium, so it's not exactly going to burn, but until I replace all this insulation with something a bit more substantial, this could all melt, and yeah, it could create a lot of fumes, and yeah, it's just generally not good. So yeah, add some protection. I will be adding it to this. I should be turning that off because that's hot. And yeah, whether I will stick with this, I don't know. I've got some other sources of heat that I may use, but yeah, add protection, guys. It's a lifesaver. You know, these things are £1 on eBay, maybe a couple of pound more for something a bit more known brand or a good quality one. Easily fitted, especially on heaters like this. Save your life, and could be one of the best things you've ever bought. But yeah, that's my advice. And you know, I'm not anyone to speak about how you should wire or do your printer, because I'm not an expert on 3D printers. But when it comes to mains electric, yeah, caution needs to be taken, obviously, and I'm doing this at my own risk, and you know, you need to take care with whatever you're doing. So anyway, here's my heater, which will soon be installed properly on a sheet of metal, either copper or aluminium. There's my chamber heater. Whether it's a permanent fixture, that heater, I don't know yet. It proves the point. It gets this chamber up to easily 80 degrees in about 20 minutes. So it does the thing that it's needed to do, and I've had this chamber up to 80 so far, which is nearly where I want it. I was hoping to maybe hold 100 degrees, but maybe that's slightly ambitious. We shall see. So Yep, there it is. New Keenovo 750 watt heat mat, ready to be installed, and hopefully be working very soon. So thanks for watching, guys. I'll let you know how I get on. Any comments on the Keenovo heaters or any experience, good or bad, then yeah, please let me know, because to be honest, I couldn't find a huge amount of feedback about these. What I did find seemed okay, so I've bought one. I'm going to try it. I needed something bigger for the area that I'm printing on, so yeah, let me know how you guys get on, and I shall put a video and update on how this one went. So thanks for watching. Cheers, guys.